Hello, I'm an old guy and I do maths. Welcome back. Um, this may be the first of the sine, cosine, or tangent graphs that you see a video for. You should know that there is also a sine graph video out there and a tangent graph one. But today we're going to look at the cosine graph. We have the function of it here, y is equal to cos x, and we are going to draw this graph. And in order to do that, we'll resort to the calculator just to give us a little bit of information. So the first thing that it would be useful to know is what the cosine of 0 is. And our calculator tells us that it's 1. So that's that point there. Now, what is the cosine of 90 degrees? Pi on 2. So this is measured in radians. So the domain of this is 2 pi, 360 degrees. The range, as you will see, is from -1 to 1. Where was I? 90 degrees. Okay, so the cosine of 90 degrees is 0. The cosine of 180 degrees is -1, so we'll pop a mark down there. And the cosine of 270 degrees, which is 3 pi on 2, cosine 270 is 0, so we are back to there. Just check that, 0. And the cosine of 360 degrees is 1. So we get back to 1 by the time we are here. Now, it's time for some of my rather rough artwork, but let's go. So this thing looks like this. And those of you who have seen my video on the sine graph will think, well, it's a familiar shape, but it's been moved to the left or right, and you would be correct. If we put up a comparison, so I've got my paperwork from that here, you'll see that probably our cosine graph starts about here, but it's as if this has all been moved to the left by 90 degrees. And perhaps you will have already seen that alluded to in some of the textbooks that you look at. Now, why does this graph look like this? Well, here's the unit circle. All values, sine, cosine, and tangent, are positive between 0 and 90 degrees. Sines are positive between 90 and 180. Cosines are negative. Tangents are positive between 180 and 270, or pi and 3 pi on 2. And cosines are again positive between 3 pi on 2 and 2 pi. So the two quadrants in which cosines are positive are the first and the fourth. And so what you're seeing here is a graphical representation of what goes on the unit circle. Now, some things to observe. The distance between the x-axis in this case, usually referred to or often referred to as the median, is called the amplitude. And in this case, the amplitude is equal to 1. Now, that is despite this point here being -1. Amplitude is a measure of magnitude or distance. We don't have negative distance, so the amplitude is still 1. And it is measured from the median point, which in this case happens to be the x-axis, to either the lowest or the highest point on the graph. Now, these graphs are symmetrical, so these two should be equal. So that is what we call that. And this distance here, the distance between where this graph starts at 0, goes through its cycle and reaches the same point, is called a period. And in this case, the period is equal to 2 pi. It takes 360 degrees for this thing to cycle fully through. Now, the other thing to say, well, there are many other things to say, amplitude, period can be changed. This can be flipped over, reflected in the x-axis pretty easily. There will be videos on this, so I'm just alerting you to the fact of such things happening. We can move this up or down, and we can move it left to right. And when we get into that, what you'll notice is that there's a striking similarity between how we do that with these graphs and with other graphs. I mean, these graphs do have their idiosyncrasies, but in general, the rules that control these are very, very much the same as those, for instance, that affect a parabola. We can dilate these, which may mean a movement in the amplitude or in the period. We can move them left to right. We can move them up and down. We can flip them. So anyway, that is the basic cosine graph. That is why it looks as it does, and it is similar to a sine graph. There's, as they say, 90 degrees difference between them. And if you want a comparison, go and have a look at the sine graph video, and you'll see that there are some striking similarities as to amplitude, period, all of that sort of thing. Anyway, thank you very much for watching. There will be more in this series. We'll get into how we move these things about. Look out also for a video on tangent graphs, which are different, and also have a look at the sine graph video. Thanks again for watching. If you found this useful, please subscribe. See you next time.